This next project, the last project on the DVD, it's going to require some very large capacity ring building, some very large diameter turning. It's going to require outboard turning on a full-size lathe. The inspiration for the chair, it's an old design. It's been around for a long time. It's essentially just a big bowl with a big round cushion. I'm going to modify it into this segmented design. First thing I'm going to do is put a center line on my paper. I'm going to make my bowl 46 inches in diameter. So I've taken this ruler and put a pen on there. But I don't know how deep I want to make it. Now let's just go for here. It's a big bowl. And I'll put another line for the inside of the bowl. Next, I'll put a top line on. The way I'm going to construct these rings is from this big beefy material. Now this material, after all the milling was done, it measures a strong 1.8 inches in thickness. But I'm going to split those rings into 3 separate rings and then put them back together to make one ring actually made out of 3 layers. I need to know what my final dimension or thickness of that 3-ring assembly is going to be. So let's do a little calculation, or a little sketch. We'll put this on here. I know when this ring is all together, it's going to have to be flattened on both the top and bottom. So I'm going to lose a little bit on the top and bottom. Now I'm starting off with 1.84 inches. So I've lost some there. And then I'm going to split it into 3 rings. So I'll have a kerf loss and a kerf loss here and here. And then those rings will have to be also flattened. So between here and here, I'm going to guesstimate, I'm going to lose another 4/10 of an inch. If I subtract 4/10 from here, plus the 1/10 there, I'm down to about a thickness of 1.34. That'll be the actual thickness of my rings in the bowl. So now I'm going to put parallel lines starting from the top, working my way down. As I've gone through this design process, it occurred to me, fortunately, that this is really maybe too big. I went back and measured the cushion that's going to go in this. And the cushion measures about 46, 47 inches in diameter. But that cushion is going to be on a curve. And so I don't need 46 inches in diameter here. I need 46 inches in circumference. So I'm going to shorten this considerably. I'm going to use the same curve, but this little curved piece of rubber here, it's about 24 inches. So I'm going to put my top, and maybe I go one more. I'm going to go up to here. So I'm going to call this number 1. This design, process or technique, it's the same as any other bowl or turning. It's just a much larger scale. Going through the process of finding the outside diameters, the inside diameters, and then doing some calculations. So I've done my layout, I've measured my diameters, I've done the calculation for my segment length. The segment lengths are based on 36 segments. If I've gone more segments than say 48, these numbers down here, these distances would get pretty short. And if I'd gone say to 24, these lengths up here would get pretty long. So I think 36 is where I want to be. I've also been very undecided on the top, where to put the top of this, and I've added one more ring. We'll call that the top ring. Originally I was going to go here, but now I'm going to go up one more. As for the cutting of this large material, it's a little different. Same basic saw setup, but the blade feed is critical. I'm cutting over 5 inches of thick, almost 2-inch thick hardwood here. And to get a perfect surface that I can glue to requires a nice, slow, steady feed. I don't want that blade to slow down noticeably. It takes a little practice, but with that practice, with a kind of a plunge, push, slow speed feed, I can get really good surfaces that really don't require sanding. However, every surface has to be thoroughly visually inspected before proceeding to the glue bottle. Now the ring itself, I can't glue this many large segments in one step or even in half rings, but I am going to do a dry fit to confirm all my angles, and they do appear to be right on. So I'll take this back apart, and to reduce the number of glue seams later, I'll glue all these together in pairs initially. Now, putting these together in pairs is no easy task either. There's a lot of surface here. First step, obviously, is to do a visual check to make sure the two pieces fit perfectly. I'm applying plenty of glue to both surfaces and applying plenty of pressure to squeeze all that excess glue out. It requires taking your time to get these just right. For the next step, I'll put these pairs together, forming groups of 4. But to do that, I'll need these little glue cauls, these little angled pieces of MDF. Some spray adhesive holds them in place. They knock off pretty easily with a hammer after the glue job. Same application of glue, making sure I've got both surfaces covered, and then the application of clamps across both sides. The little glue cauls are really necessary to keep that clamp from slipping. The final step here to get 2 half rings is same as any other ring. I'm doing a half ring technique. I'll be using 2 hose clamps because the ring is thick enough or tall enough to accommodate 2. I've put glue on all the surfaces. I've got little half dowels there and the pair of seams to make half rings. And as I tighten this first ring, I'm looking at my alignments, keeping things level and all the points aligned as best I can. I did do a dry fit before the glue job to confirm everything was in order. Here's the second hose clamp. Again, checking the levelness and just tightening it up as tight as I can get with a handheld large screwdriver. This is how I did these half rings. It's big stuff, takes some time to do. So here's my stack of half rings. Next step is to get smooth surfaces, top and bottom surfaces. I'll take advantage of the size of the half rings. They will go through my drum sander before they're whole rings. Even these large diameter half rings, if I just slide them, articulate them sideways as they pass under the drum, I can pass this large half ring through the drum sander. I'm using just 36 grit paper at this stage. Now to split these, I'm going to first knock off the corners so they'll pass smoothly through this bandsaw. I've got a high fence there to give me good support. I've got a magnetically held feather board there, a sharp 1/2 inch blade, and I'm making very slow progress through each one of these rings, cutting them into 3 pieces. And then back to the drum sander, 36 grit paper initially, and then finishing these off with 80 grit, getting them ready to be joined into full rings. This is a long, lengthy process. A lot of work to put these rings together. Now to put the 2 halves together on all these rings, just a little touch-up, eyeballing this and getting perfect fits between the 4 ends. I've elevated the half rings with these little posts of MDF, applied glue. I'll use a rubber band going from a clamp to a clamp. That'll give me adequate pressure across there. no need to put a clamp all the way around this huge ring. And then a couple more spring clamps give me very level surfaces from side to side. Of course, the seam on the opposite side, same procedure. A couple of anchor clamps with a rubber band going across, and then 2 more little spring clamps to keep those 2 ends very level with each other. Now, before stacking these 3 rings, I need to do just a little bit of sanding block work on those final seams. It doesn't take much. The rings are so big, I really don't have room in my shop to glue these, so I'm doing it outdoors. It's a cool morning, so that's an advantage. I've done a dry fit here, indicating a center point between 2 seams, so I can line up everything. I'll put some blue tape on here next, and then split the blue tape with a knife. So I've got a quick reference on positioning these before I apply my clamps. Now, there's a lot of glue to spread. You've got 4 surfaces, 2 seams, and you got to work fast. I've laid out my clamps ahead of time. I've got a nice plastic wide putty knife there to spread the glue very quickly. I've got the first seam spread. Now I'm working on the second seam, lining up my tape and applying clamps as fast as I can. There's a clamp on every seam on the outside, a clamp on the middle between seams on the inside. That's 72 clamps around each one of these assemblies. Then as the rings get wider outside to inside, I need even more clamps to get pressure on the center of the segments, and then the widest rings require even more clamping towards the middle of the segments. Here's all my rings, been laminated, 3 layers each. It's now finally time to start doing some turning. Long before building the rings, I made this large 46-inch diameter 3 layers of MDF disc. I've got an 8-inch faceplate being mounted here. I made this early on so the glue would totally cure and any movement would be, ended. I've rigged up a come-along hoist system. This weighs probably, I would guess about 130 pounds or more. But it needed to be big and beefy to reduce vibration, these large diameters. I've got to true it up. It's not running quite true enough. I want it perfectly flat before I start mounting things on this. I'm scoring some lines, just a little bit of an alignment aid as I mount things. My son Andy built this outboard tool rest stand. It works really well. It's quite heavy also. Before starting the turning on these rings, I've created a new blueprint using the exact dimensions. Each ring has a different thickness slightly, and they're slightly oval here and there. I want to know exactly what I can turn, so I've created a new blueprint using the final dimensions of my finished rings. This will enable me to produce rings that will exactly conform to this new blueprint, which is important because the rings are going to be connected to one another after they're turned, but they're not going to be turned as a unit. Now, the mounting requires screws with washers. I'm putting 8 of them around the inside of this. Of course, I can't turn on that inside because of the positioning of the screws. But I can work on this outside edge and that corner. I want to match up my diameters perfectly with my blueprint. These individual rings that I'm going to turn are not going to be glued together and turned as a unit. So each one needs to be precisely dimensioned as I drew that second blueprint. I can sneak up on the diameters using my ruler, comparing it to the blueprint. Here's an outside diameter that looks like it's pretty close. My inside, I've still got to take a good 1/4 inch or more off the inside, but that's later after I remount the screws. The wall angle I can mimic by creating a little template with 2 pieces of straight edge veneer, and that'll allow me to get that angle to match my blueprint. Here's another tool that works pretty well, one of the Easy Wood small round pointed scraper tools. however you remove the wood. I mean, it's whatever style turning you like to do, whatever tool you use. But here I'm drilling another set of holes on the outside and remounting with screws and washers, holding that outside so I can remove the inside screws. It's still running perfectly true. Now I'll remove wood on the inside and sneak up on that exact diameter, comparing this ruler stick with my blueprint. I can also check the wall angle on the inside with another little template. I can check the ID of the inside here. Two sticks clamped together with pointed ends. I'll go right over to my blueprint, compare, sneak up on a perfect diameter match. Each ring, gets one chance. I can always remount, I suppose, and do some modification, but I don't want to have to do that. A little sanding here. Now I can take this off. I'll turn a little recessed groove, very shallow, probably only like 1/8 of an inch or so deep. So with this turned around, reversed, I can turn the underside or the smaller diameter side. I'll mount some screws on the outside here. It's got a tapered surface there, so these screws, number 14s, can squeeze up against the tapered edge. That piece of tubing protects the wood from getting marred. Using my ruler, checking diameters, doing some sanding, and now I'm turning a little groove, about 1/8 of an inch wide, about 1/4 inch deep. I'll use splines to align all the layers together, so everything will have these grooves turned. For the rest of the rings, I reverse the order of turning. I turn the underside, the small diameter first. Now preparing to do the inside. I've done my groove, I've checked my angles. Now I can turn it around, center it again, and turn the inside. This is the big end facing outward now. Same kind of procedure with the little pieces of tubing, and take the screws off the outside. The last step would be to round those edges and turn a groove that fits the adjacent ring. I've got a little device here. It's just a stick with a spline material attached to one end. It's split with a small piece of spline material clamped in place, so I can compare one groove with the other. It works out pretty well to get them matched up. And I'll do a test fit before taking the ring off my big MDF disc, before proceeding to the next one, so forth and so on. Regardless of what kind of lathe tool you use, one thing's for certain, you've got to be careful. These are large diameters. The tip speed can really get moving if you crank up your lathe speed. Just take it slow and easy and be careful. On some of the wide rings, I put these little grooves on to minimize any glue migration during the assembly. And the smallest ring has been prepared to receive a disc. You'll see that a little bit later. The finish process: 2 coats of sanding sealer, 3 coats of gloss poly, and a final coat of satin poly, all buffed in between coats. So now it's time to build a base, a pedestal for my chair seat, and at the same time I'm going to do a footstool. These will be constructed the same way. These are rough blueprints to get me started in building the rings. I've done the same technique, built thick rings, split them on the bandsaw, done the flattening with my drum sander, put the half rings together, made those smooth, and stacked those into units of 3 layers. Now, using the actual dimensions of my finished rings, I've created a more accurate blueprint, one that I can transfer angles and dimensions, diameters, as I turn my individual rings, just as I did on the chair bowl. The seat is going to be supported by this device. It's a swivel, spring-loaded rocker. It requires a platform, which I'll embed. The footstool, here's the actual dimensions, and it'll have a 15-inch diameter cushion sitting on that shelf. Here's the actual dimensions on the chair base. I really screwed up here. almost really screwed up, but I caught it in time. I'll show you here in a second. The numbering of my rings, for some reason I duplicated the number 4. Fortunately, I caught it in time. If there's a way to make a mistake doing this stuff, we find it. The rest of the procedure on the turning was all the same. Mounting and turning, flipping it around, mounting it again, checking those grooves for the splines, just going through my stack, getting these ready for finish. Here's a platform for my seat base. I've created a shelf there, the thickness of my MDF layer, 3/4 inch. So I've got a support. And here's all my finished rings ready for finish. On the top ring of the footstool, I've created an oversized bead, something to use as a handle for moving the footstool around. It's finally time to stack the rings. I'm drilling a series of holes. First, the oversized hole for the screw heads.